There's actually a very interesting kind of pressure that comes with speaking in the first session, which is something I have never experienced before. But I'm confident that we will pull it off. And if we don't, I think let's all just begin by making a pact here together that what happens in room 4 stays in room 4. And with that housekeeping out of the way, good day, everyone. My name is Knowledge. I am a software engineer at BBD. Welcome to my talk, which has a very long title. And I was sharing the wrong screen there, but it's fine. We will get to it. I need to switch stuff here. Sorry. There we go. Um, Welcome to my talk, which is about a very human thing, that is the desire for control. And we will be exploring this desire through my experience with reverse engineering and infrared TV remote controller using an ESP32 microcontroller and the flutter framework, bringing a modern meaning to an old age desire, that is control. Now, the history of human civilization is a story of our relentless pursuit to control various elements of our surrounding environment. From the discovery and control of fire to the crafting of tools, weapons, and shelter out of flint, stones, and bones. From inventing the steam engine to the latest state of the art technologies like AI, quantum computing, and immersive experiences with virtual and augmented reality, this pursuit has fueled some of the greatest mind blowing innovations of all time. But somewhere along that timeline of technological advancement, our desire for control evolved. We began to embrace our natural tendency towards laziness, and what began as a quest for survival became a thirst for convenience, an attempt to automate almost every function that requires some kind of effort from us. We strive to have power and control over any and every inconvenience that somewhat acts against our desire to not have to do anything. And this is something that is still driving innovation to this day. It was through this evolution of our desire for control over inconveniences that the first TV remote controller was released in 1950 by Zenith Radio Corporation, a picture of which can be seen on the screen behind me. This wired remote controller, appropriately called Lazy Bones, afforded people the convenience of controlling various TV functions from the comfort of their couch, provided, of course, that the wire was close enough to the TV. Provided, of course, that the couch was close enough to the TV for the wire to reach. Sure. Okay, we are back again. Sorry for that. It's Thank you. um, so we were still talking about the blab, or we were still talking about Lazy Bones, the first remote controller that was released in 1950. And this invention was a game changer, so much that people were willing to overlook its hazardous nature for the convenience of not having to peel themselves off the couch every time they wanted to turn up the volume or change TV channels. Then in 1952, way before the invention of the skip button, as we are commonly familiar with today, the blab off TV remote controller was released. And this creatively named magnificence only had one job, and that was to mute annoying commercials so that they did not interfere with the TV experience. A testament to the fact that people have been turned off by adverts for over 70 years, which is probably why most streaming platforms sell their premium packages by offering an ad free experience even today. Fast forward to more than 70 years later, The remote controller remains one of the most common occupants of living rooms, presenting us still with inconveniences, ones that we are yet to gain control over. Whether it's a rivalry over who gets to hold the remote, a desperate search through couch cushions, an unsanctioned store run for batteries, or maybe it's the frustration of having to type long strings of text using on screen, using physical navigation buttons on the remote controller. Most of us have experienced at least one of the many small but real inconveniences that come with TV remotes. So, in a time of smart TVs with internet connection capabilities and numerous streaming platforms that have unintuitive, incompatible on screen keyboards, I found myself faced with the frustration and inconvenience of having to use these on screen navigation buttons to search for content, or worse, enter a password, to which making a mistake means having to redo the whole process all over again, with no guarantee for success the second time around. So, following on this tradition of eliminating inconveniences through devising some means of gaining control over them, I decided to stand on the shoulders of giants who came before me by doing what any self respecting engineer would do. I decided to build my own remote controller app using Flutter and an ESP32 microcontroller. Gaining control over something generally requires a way to transmit input or issue commands to it in a language that it can understand. So, in looking to build this remote controller app, my first thought was that the application, being my instrument of control, will somehow need to know how to talk to the TV. And because of that, I embarked on, which one is it sharing now? So I embarked on a short-lived search for my TV's API, which, to those who don't know, is a manufacturer-defined interface through which I would be able to send commands to the TV. But Hisense, like most TV brands, doesn't provide such an API, which meant that I couldn't rely on a translator to speak to the TV on my behalf. And I would instead have to learn the actual language that is understood by the TV and then find a way for my app to communicate to the TV using such a language. Going into all of this, I knew that infrared remote controllers work by sending encoded pulses of infrared light towards the receiver that's on the target device, which in my case would be the TV. The receiver then decodes and translates this received signal into an instruction that the TV can execute, and the TV would respond accordingly to such a request. So when you press the power button on a remote controller, for example, a specific encoded pulse of infrared light is sent towards the receiver on the TV, and the TV responds by toggling between power on and power off. This is, of course, if the encoded signal that was sent to the TV uses the same standard as what is used for that model and brand of the TV, as these are not standard across all devices. One thing to note, though, is that the infrared receiver on the TV doesn't really care about the source of the signal it receives. If it is encoded using the correct standard, the receiver will translate and decode that signal into an instruction that the TV can execute. So this basically means that anything that can speak the same language as the TV's remote controller, for example, can actually be used to mimic the remote, and the TV will still respond accordingly to requests coming from such a device. It was this understanding of how infrared remote controllers work that got me started on a three-part journey, which I call the reverse engineering trilogy. And this is where I aimed to get access to the actual language that is understood by my TV so that I could gain control over how I communicate with it. And coming into this idea, I somewhat felt the need to be dramatic and base each of the different parts of the trilogy on some movie or TV show, which, just like myself, you are in no way expected to be familiar with for the purposes of this talk. And so, with all that out of the way, we can dive into the first part of our reverse engineering trilogy, which I will call Signal Heist. This is where I set up a hardware and software system to intercept and capture signals that are sent out by the physical remote controller when certain remote buttons are pressed. The idea of this system is to build a dictionary or vocabulary that allows me to translate user instructions or intention into a language that the TV can understand. We can think of this as an eavesdropper who listens to a secret conversation between two different parties, learns the communication protocol used by those parties, and then goes on to mimic one of them moving forward. The signal heist system will consist of an ESP32 microcontroller. That is the device that you see highlighted by a green box around it. And this is a cheap programmable mini computer that supports both Wi Fi and Bluetooth for wireless communication. The system also consists of a VS1838B. That's the device with three legs coming out of it, highlighted in yellow. And this is a widely used and commonly available uh, infrared receiver module that has an operating voltage compatible with that of the ESP32 microcontroller. These two components are connected in such a way that when I press a key on the physical TV's remote pointed at the receiver intercepts the infrared signal sent out by the remote, converts that into an electrical signal, and then feeds the result of that conversion to the microcontroller, where I'm able to read off the value of the signal received in text format. This text will consist of one, the encoding standard that is used for that particular device. It will also consist of an address value that just specifies which target device we are talking to. And finally, there will be a unique signal or code value that is for that particular function that we clicked. NEC is the most commonly used protocol for infrared communication. It generates its encoded values by multiplying a unique data value or coded signal with a carrier signal that has a frequency of 38 kilohertz. And this multiplication of the two produces a modulated signal that gets transmitted to the TV for the receiver to decode and translate into an instruction that the TV can execute. So the text formatted values that I got from actually clicking on the remote and having them printed out from whatever the receiver gets um, allowed me to implement these handler functions. Of interest there is the one I think highlighted in green. The functions simply send out a specific NEC encoded value based on the TV functionality that is required. So if, for example, we wish to toggle between power on and power off, we would invoke, in this case, the toggle TV power function, and the microcontroller will trigger the sending out of an infrared pulse that has the address value, in this case, of 0xB00. That just identifies the target device, which is the TV. It will also send a code value, which is 0x0D. That is not really important. It's just that it's unique to what we actually get when we press the power button on the remote. And this is similar to exactly what you would get if you were pressing the physical remote for that particular TV. And so when we do something like that, simulating the sending out of those similar signals allows the TV to respond uh, to those requests that it's getting from the device. And so with the handler functions implemented, I now had the vocabulary of the TV mapped out, which meant that I could move on to the second part of the trilogy, which I will call the imitation game. And this is where I built the actual circuit that would use those handler functions to imitate the TV remote in response to requests sent to it using the infrared LED transmitter. The circuit for this system consists again of the ESP32 microcontroller, which is the brains of this whole operation. And then we also have an infrared LED that is the dark bulb-like looking component highlighted by the red color over there. And this is used to send an infrared pulse to the TV when it is switched on. The system consists again of a transistor, that is the component, the rectangular dark component highlighted in yellow there. And this just acts as a switch that sends out, that triggers the sending out of an infrared signal, or whether or not we are sending it or we are not, based on the transistor being switched on or being switched off. And then finally, we also have some transistors, which are the striped components that are used to control the amount of current flowing into the infrared LED, as well as what's coming through the base of the transistor in that case. This circuit has its components connected such that when one of the handler functions is invoked in the microcontroller, an output signal corresponding to the encoded information for that TV function is sent out from the microcontroller to the transistor via a 1 kilo ohm resistor. The transistor in this configuration, as I already said, acts as a switch, allowing current to flow through from the base to the emitter of the transistor when a high enough signal is received at its base, causing the infrared LED to switch on, and a pulse of infrared light gets sent to the TV corresponding to whatever TV function that we want. If the LED is pointed to the TV when this happens, then the TV, not caring about the source of the signal that it received, it's going to execute whatever instruction that we just sent to it. Just a side note, having last worked with electronic components a couple of years prior to building this circuit, I was humbly reminded of the power and convenience of Ctrl Z after I tried to remove the only LED I had at the time from a powered breadboard by grabbing both its terminals and pulling it out, causing a short circuit that left me with bent fingers, a bent LED, and a mandatory trip to the electronics store for more components, because in electronics, there is no undo button. If it's bent, you have to get another one. So I am tempted to say that if there's one takeaway to carry out of this whole talk, it would be appreciate the little things, because I know from my experience that is something I definitely took with me. But back to business, we now at this point have the capabilities of providing a command to infrared signal translation service. And so after that, I decided to convert the ESP32 microcontroller into an HTTP server listening on the standard port 80. And it only has one endpoint configured that is really useful, which is the command endpoint. And the command endpoint just basically takes as a query parameter a key, which indicates the instruction that we want to send to the TV. And it handles incoming requests by extracting whatever command key that it received, then delegating the rest of the processing to the trigger command function, which I am going to show just a second, which is now. So the trigger command function, upon receiving the key string as an argument, checks to see if there's a handler function for handling the command defined by the received key. That's what is happening in line 34. And it does this by searching through the key to signal map dictionary that is defined in line 42 to 49. And it is searching for a matching key that matches the passed in argument that we received. And in the event that the key is mapped to a handler function, we invoke that handler function in line 35, causing the microcontroller to switch on the transmitter, which triggers the emission of infrared light from the LED. So if the received key is power, for example, then line 43 tells the server to execute the toggle TV function in service to that request. And so with all that setup done, We basically have a translation server that accepts a command request on one of its endpoints and then communicates the command to the TV, bringing us finally to the last part of our reverse engineering trilogy, which I will call Control Unchained. This is where I built a Flutter app to act as my instrument of control by being the client to the server that we just discussed, allowing me to send commands to the TV using an interface of my choice, while also allowing me to search as well as change passwords on the TV using a more familiar phone keyboard, using the force of habit in this case. The one motivation for even involving all the hardware stuff that we just talked about was that my TV didn't have an API through which I could send commands to the TV. And I was just not comfortable with that limitation. Uh, APIs usually abstract daunting complexities of systems, which, given the choice, we would otherwise not want to even tackle, as they just stand in the way of the end goal. So, with all that hardware setup out of the way, I was finally ready to unleash the might and power of the Power Stone into the living room. The first thing I did with my newly found powers was to implement what is pretty much a clone of the physical TV remote controller. And I was quite satisfied with it for a little while, as it marked the end of the occasional search, of the occasional need for new batteries, as well as the more common search across couch cushions, which usually leaves a very unwelcome chaos in its wake. Um, and this was good because with the remote controller now on my phone, I know that there's no way that it is getting lost because it is pretty much an extension of myself at that point. But then it then dawned on me that I wasn't really using the full potential of what I had just built. Navigating on screen TV keyboards for searching or entering a password has always been one of the most frustrating things about working with classic TV remotes. I must click the remote way too many times than I need to, navigating up, down, left, right to the particular key that I'm interested in typing out. So I did, but now that I had the power, I decided to fix that by getting the app to allow me to perform those operations using the more familiar phone keyboard, as I just said. Um, because with great power comes great possibilities. The idea of it was simple. I type in a search text or a password on my phone, send that through to the ESP32 server, and the server would type out the search text or password for me on the TV by clicking the remote's navigational buttons on my behalf. The limited vocabulary of the TV, though, presented a challenge to this idea, as I can't directly send text to the TV because it only understands a small set of infrared pulses corresponding to whatever TV function that comes defined on the remote. So, with that, I had to find a solution of handling that challenge that I just experienced. To overcome it, I got the app to generate the correct sequence of navigational clicks that I would normally have to go through while searching on a particular platform, say Netflix or Showmax or whatever the case may be. I then send out that sequence of corresponding command keys for each click to the server, with which fires off infrared signals for each command key, simulating the searching experience. And I can do this by selecting a keyboard I want to type or search on, enter a query text like escape maybe, and the app will generate the correct sequence of clicks that I need to go through to actually search escape on the TV. So getting the app to search and type for me on the TV was again a very huge milestone. And yet I was still not satisfied because now I was like, why do I even have to type? Why can't I just tell the TV what I want it to do and it does just that? I mean, surely I don't have to use my fingers for something like that. It is again too much work for me. So I then went ahead and integrated a speech to text converter in the app, which then allowed me to control the TV by talking to it. And thinking about that now, it feels like an unnecessary use of my voice as well. So, so maybe the ultimate control would be if the TV could just, read my thoughts and act to my will. But I think it's too late to have that for this talk now. So that will be a story for another day. And because of the glitch that happened earlier on in the talk and the remaining time that we have, I did promise that we will have some practical insights coming out of this talk. And if a picture tells 1,000 words, then I am thinking an actual showing of what I've been talking about will paint an even better picture at that. So, with that said, I'm just going to go ahead and show you what I have been talking about. Starting with, I have this little circuit here, which to those who can see is a very messy looking circuit, which I know that if my electronics lecturer was here, she would not be impressed. But I don't think she is. And if she is, then what happens in this room stays in this room. So we are fine on that. So I built this little circuit here, and I'm just gonna exit the presentation for a bit. We have okay, cool. So we have here code that's already running on the ESP32 microcontroller, but I'm just showing the console because that's where I want you to see the output of what happens. And I have my physical remote controller here. And the first thing that I'm going to do, there's a receiver on this little circuit that I spoke about. I'm going to click a button pointed to this receiver, and you will just see what actually gets sent by the TV remote when that happens. So I'll click the power button, and you will see something like that where there will be the protocol that's used for the encoding, the address value corresponding to the power button, as well as the target device, which is specified also in the console. So that's what I used to implement the handler functions I spoke about. But that is not the most important part of what we came here to see. So I'm going to pull this thing off and connect it to my battery. And put it in front of the TV because we need to, for whatever reason, point to the TV's receiver when we want to control it. But maybe that's something we can fix again at another time. I also then will go I'm going to start up the app that I spoke about, which hopefully will not present any technical difficulties. And then I will also go on and hopefully be able to open the phone screen with whatever that is running there so that we are able to see as I click through whatever that this is what's happening there. And it's taking its time, but it's fine. Yeah. So again, because of time, I have the app running here on my phone. And if it's not going to share the screen, then I'll just go ahead and, oh, okay. It seems like we are there or not. Sure. It's fine. I'll just run the app on the phone without showing it, and then we will have it do what it does. Okay. And that is again taking its time to start it over there. But anyways, it doesn't matter. I have the app. First thing I'm going to do is try and power on the TV because that is the most useful thing that we need to at least do. So I clicked the power button on the app and the TV switches on. Thank you. And the next thing that I would like to do, obviously, is connect this thing to internet, because these smart TVs don't really do anything without internet connections. So I can click the home button, opens up the settings, and I am able to go to network, and we can go there, and it's going to look for whatever available networks that are there. And for whatever reason, it's already connected to my hotspot. So I'm not going to show that again, but I'll go to Netflix, because we always have to go to Netflix for whatever reason. And I'm going to click the back button. And the first thing that then I want to be able to do is say, let's do that. Let's search for escape. I'll just do it again. So we start from the start position, because this thing isn't really smart. It doesn't really remember where it is. So I'll open here on my phone. Again, there's a search dialog, and I'm just going to type escape and click OK. And we can start seeing it typing that for us. And it didn't, but it's fine. It's fine. Again, state management is really an issue with these things, because they don't really know about each other. It's all about, just hacking it to do whatever. But with all that said, suppose, for example, we did get some results, search out of it, and we wanted to watch something like, I don't know, Wednesday, for whatever reason. If I had found that as a search result, I would still have to navigate to Wednesday by clicking on my phone. And that is, again, something that is very annoying to do. So instead, I'm just going to talk to the TV to tell it to move to Wednesday, which is like what? 5 to the right. So let's try and do that. Move right times 5. And not sure if it picked that up, but I'm going to try it again. Move right times 5. I think because of time, let's head over to the last parts here. So this whole experience of the chase for control reminded me of the words, and I need to switch these two. Sure. What happens in room 2? So this whole experience of the chase for control over inconveniences reminded me of the words by an English philosopher, L.P. Jacks, who said, after observing the desire for control that we have as humanity, the mechanical mind has a passion for control of everything except itself. Beyond the control it has won over the forces of nature, it would now win control over the forces of society, of stating the problem and producing the solution, with social machinery to correspond. And this was a warning to the idea that in seeking to control nature and society with mechanical precision, the mind risks ignoring its own limits and the humanity of those it seeks to govern. So, living here today, I would like to encourage you to be curious. Don't be afraid to explore. Don't be afraid to get your fingers bent a little, and have fun while you are doing it. But above all, in this journey of control, perhaps the greatest mastery we can achieve is not over, we can strive for, is not over the world around us, but over ourselves. But above all, the greatest control we can hope to achieve is not over all these devices and gadgets, technological, whatever that we know of, but it's over how we choose to engage with the world and with ourselves. And with that, thank you.
Sorry, due to time constraints, if there's any questions, we're only going to take two. High knowledge. Thanks so much for the talk. Very, very insightful. I just have one question. The TV doesn't care where it gets the signal. Does this apply to like cars and other types of remote? And what does it mean for security?
Well, I'm not sure what cars use, but infrared receivers don't care. And if they're using the same, unless there's some proprietary software running on that to block sort of like or to only select the input signal coming from a specific place, then it won't really care. So that's why even to try and build this whole thing, the first thing that I needed to do was to just implement the toggle TV power function and see if I can turn it on and off. That was to avoid there being some proprietary blocker that prevents me from being able to do that.
All right. Thank you so much.
Hazard. First of all, this is so cool.
Thank you.
I checked on our Wi-Fi list. Is your device called ESP_AP?
I did create an AP at some point, but I did away with that. But when I power it on, it also opens up the AP. So,
Okay,
but it's
cool.
not being used for
That was
anything.
my question: was how you're connecting to it
Yeah,
from your
initially,
phone to the AP.
yeah, initially that's what I was using because I wanted the phone and the ESP32 to be on the same network. But instead, now I just use the hotspot because again, it's connected to the hotspot on my phone and
No,
not have
perfect. That,
yeah.
that was my question. Thanks.
Yeah.
High knowledge. Oh, fantastic talk, man. I'm just curious, besides the ones that we saw here, what are some of the interesting edge cases that you ran into while building this thing?
Sure. I feel like a lot of the things that I wanted to implement, sort of like the biggest challenge that I had, I think it was state. Like for example, if I use the physical remote now to move it to a different place, for example, none of the systems that I built here know that I did make that move. So now the two are out of sync. So if I try and send anything, the app thinking that the TV is at this state, it's just gonna fire off a bunch of signals, and you will just see a bunch of chaos over the TV, which is not great. That's just one, but I think we can talk about more after. Thank you.